Okay, chapter 21 notes on more about tests. Okay, so we've talked about hypothesis testing and we are continuing the conversation, and here's more information about p-values. So remember that the p-value is, we talked about, that's what's happening in the tails once we have the null hypothesis and we're testing some observed value for the null hypothesis. Well, another way to look at it is that a p-value is really and truly a conditional probability. And this takes us back to the last unit that we did when we talked about probability. So that p-value is the probability of an observed value given that we're looking at the null hypothesis. It's not the probability that the null hypothesis is true. So that's really important. If you're confused about that, or if that's what you think, that's not it at all, okay? It's not the probability that the null hypothesis is true. What it does tell us is that it's the probability of getting results at least as unusual as the observed statistic, given the null hypothesis is true. So we're comparing that observed statistic against what the null hypothesis says, and then we're saying, well, we have enough information here to reject the null hypothesis, or we fail to reject it, because we never say that the null hypothesis is true. We're just trying to say, well, okay, what's going on, and when we compare that, okay? So the probability that an observed value what that observed value is, given that we're looking at the null hypothesis. So the lower the p-value, the more comfortable we feel about our decision to reject the null hypothesis. Okay, the null hypothesis does not get any more false. The null hypothesis is what it is. Okay, so remember some examples in class is we looked at a p-value being all the way down here and saying it was very, very tiny. And we said that, okay, that we feel pretty good about rejecting the null hypothesis. Okay, well, here comes an actual measurement that we can compare to, alpha levels. And the symbol that we use for an alpha level is this. It's a Greek letter alpha. Okay, and we can define a rare event by setting a threshold for our p-value. So our alpha is what that threshold is, and we say, okay, at this point or at this number, we're going to say, all right, the p-value is where we think it is, or it gives us enough information to reject the null hypothesis. Okay, so if the p-value falls below this point, then we say, yes, we can reject it. And if it falls above it, then we fail to reject the null hypothesis. Okay, so that threshold or that value is what's called an alpha level. Okay, it's the threshold that we choose, and we say, okay, this is where I think the p-value should be, and if it falls below that, then we reject it. These are the three most common levels. Okay, so 0.01 is smaller than 0.10. So you have to make the decision as to what makes most sense with the data that you're collecting. Okay, so these should be in your notes, what an alpha level is, and these three values for an alpha level. Okay, it's also called the significant level. So now we are finally able to say statistically significant. Okay, so if a value is statistically significant, it means that it had a very rare chance of occurring, but it actually did occur. So the probability was very small, or that p-value is very small, therefore it is statistically significant at that level. So those are the magic words that you add to your conclusion. We reject the null hypothesis because the test, and then whatever the statistic was, it was significant at that level. Okay, so that's where the alpha level comes in. And you choose what the alpha level is. You have to look at what your problem is and what your scenario is and what you're actually hoping to conclude, and then you make a decision how small you want that alpha level to be. The important point here is you must choose the alpha level before you run your experiment. It seems rather fishy or a little strange to run the experiment and then make the decision as to what the alpha level is. Okay, but so that doesn't go that way. You set all of this information up, the statistics that you're going to use, what the alpha level is, and then you run your experiment and see if it met that level or not. Okay. Okay, well, So here's an extra piece of information that you may have wondered, well, what happens if the success or failure condition fails? If we're looking at very small samples, we're not going to have the success being greater than 10 and the failure being greater than 10. Okay, so we make a very small adjustment to a calculation. Okay, so we add some phony observations so that we can have an appropriate p-value. Okay, so we add 2 successes and 2 failures. So what we do is, because normally we have the successes divided by the total number of, or our total n value, the total number of, I don't know, people who are in our sample that we're looking at. Okay, so in order to adjust it by 4, we add 2 to the numerator and 4 to the denominator, and that gets us up over that 10 threshold. Now, it is important that at the end that you would make a comment that you had a small success failure condition and that you had to make an adjustment so that it seems more fair. But this is what you would do if you have it very small. Okay, so the little, it looks like a tilde. So that tilde on the top means that it's because the sample is so small, and how we make a confidence interval. So it's really, this is the same, but we use this tilde to show that it was adjusted, and it's for this smaller sample. Okay, all right. So it has the additional advantage that we no longer need to check for the success or failure condition with that if it's a small sample. You don't always do this, just if it's a small sample. Okay, so here's the back to the kind of fuzzy gray area in statistics, but one that it's important to mention, or not important to mention, it must be mentioned. Okay, so nobody's perfect. Sometimes we make an error when we're making a decision. Remember, we just go by that one sample and we decide, oh, yep, it's smaller than the alpha level, it's significant, yet we fail to reject the null hypothesis. Well, some mistakes can happen. Okay, so sometimes there are 2 different situations of mistakes that can happen. Okay, one is that the null hypothesis is true and we accidentally reject it. That is a type 1 error. And this is going to be the next few slides. So if you don't get it down now, or you can pause the video and get this written down, you will have plenty more things to add to your notes. So that's a type 1 error, that the null hypothesis is true, but we mistakenly reject it. The second one is the null hypothesis is false, but we fail to reject it. Okay, so those are the 2 opposite things that can happen. So we have a type 1 error and a type 2 error. And let me point out, with AP Stats, you don't have to calculate if it's a type 1 or type 2 error, and there's another word, power, that is going to come into play here as well. You don't need to calculate any of those, but you do need to understand and be aware of what those words and definitions mean and how your data can affect those and what you do with that information. So we're not going to have any calculations, but it's an understanding that needs to happen. Okay, so this box is important to have written down in your notes to help give you a visual as to what this looks like. Okay, so one type of error could be more serious than the other, and it depends on the situation, and we're going to look more at this tomorrow in class. Okay, so which type of error is more serious depends on the situation at hand. The gravity of the error is context dependent. So it depends. Is it a high cost error if you make a mistake in one direction versus the other direction? Okay, if you make a type 1 error, you reject it when it was really true, it could cost a company a lot more money if they have to send something back. Okay, if it was truly false and you kept it, well, how bad is that going to be as well? So again, we'll have more scenarios and we'll talk about that, but that's the decision-making process. Okay. All right. With a type 1 error, the probability of a type 1 error is alpha. Okay. And that's one thing that needs to be remembered from this, all right? Because it's the alpha level, the p-value has to fall below that alpha level, so the probability of a type 1 error occurring is whatever that alpha level is. Okay. All right, a type 2 error occurs when the null hypothesis is false, but we fail to reject it. Okay, so we assign the letter beta, which looks like this. Looks like a italicized B, and yes, it has this little tail on it. Okay. The letter beta is the probability of making a type 2 error. Okay. And here is the next word that we're looking at is power. Okay. The power of a test is 1 minus beta. And the power of a test is a test's ability to correctly detect a false hypothesis. We want to be able to correctly detect that. We want to be able to change things so that we can avoid that happening, or at least be able to discuss what the possibility is. Okay, so here's more about the power of a test. The power of a hypothesis test is the probability that the type 2 error is not committed. It's the ability to detect a false null hypothesis. And here's the big important information for increasing the power. So increasing the sample size increases the power. I have some graphs I'm going to show you in class tomorrow that will help you have a visual attached to that. Okay, so all of these things balance out. We can't have all of this, we can't have everything, okay? So they work in opposites. If we want to limit a type 2 error, then we need more power, but that makes the alpha higher. So the beta and the alpha go together. Okay, so we'll talk about it again tomorrow because this needs a lot more visuals that go with it. Okay. All right, here's a little bit more. So here's what they do is they look at, well, let's look at what the hypothesis would be if we accepted, or if we looked at what that beta value was more specifically. So here's the original comparison of errors. Okay, so it says suppose the null hypothesis is not true. And this one is suppose the null hypothesis is true. So if we suppose the null hypothesis is not true, then what we're looking at is power. And then this in the tail is where beta is, because we either reject the null hypothesis or we fail to reject. So you see that there's more power, beta is bigger, and the alpha is smaller. So if we look at a larger sample size, well, what happens? When we talked about this earlier in chapter 18, as we increase the sample size, the standard deviation gets smaller and smaller, the standard error gets smaller, therefore the alpha gets smaller and also the power gets larger and the beta value gets smaller. So the way to combat some of these errors is to have a larger sample size, because we will be more confident that we're making the right choice. Okay, so here's a summary of what we have learned so far. So there's a lot more to hypothesis testing than just saying yes or no. When you're looking at a small p-value, it indicates evidence against the null hypothesis, not that it's true. The alpha level establishes level of proof. It determines the critical value that leads us to reject the null hypothesis. And that the hypothesis test gives answer to decision about parameter. The confidence interval tells us plausible values of that parameter. Okay, so the hypothesis test and the confidence interval are certainly related to one another. Okay, but the hypothesis test is just saying, well, what do we know about the parameter? And then the confidence interval is saying, well, inside what values do I expect that true proportion to be? That's the slight difference between them. And the other thing that we've learned is the two kinds of errors that we can see and how to combat those. So the type 1 error is this alpha, type 2 error is beta, and the power is the probability we reject a null hypothesis when it's false, and that's, okay, and it says we reject a null hypothesis when it's false, and that's 1 minus beta. And the larger the sample size, a larger sample size will increase power and reduce the chance of both kind of errors. Okay, lots of information in here with alpha and beta and the different types of errors that there are. So make sure you have some of the pictures drawn in your notes, and we'll continue this conversation tomorrow. All right. That's it for chapter 21.